Today we're on page 4 of our Chapter 10 notes packet, Section 10.3, finding the remaining trig function values when one function value is known. For example, the first one we're going to look at, we have if the sine of our angle theta is equal to 5/13 and theta is in quadrant 2, we want to find the remaining trig values, meaning the cosine of our angle, the tangent, cosecant, secant, and cotangent of our angle. So these are the steps we're going to follow. You were going to draw and label a triangle in the correct quadrant. Again, please beware of the signs, the S-I-G-N-S, and use Pythagorean theorem to find the third side, and then just use SOHCAHTOA. All right, so back to example 1. If the sine of theta is equal to 5/13 and theta is in quadrant 2, so we'll draw our right triangle in quadrant 2, and the sine of our angle theta is equal to 5/13. So in other words, sine is opposite over hypotenuse. So the side opposite, angle theta, is 5, and the hypotenuse is 13. So our hypotenuse of our right triangle is 13. Use Pythagorean theorem to find the third side. All right, so in this case, well, hopefully you might know this. This is a triple of 5, 12, 13. But if you didn't know that, then we do 5 squared plus b squared equals 13 squared. 25 is 169. Subtract 25 from 169, that's 144. So our other leg of our triangle here is 12. Okay, now this is a negative portion of our x-axis, so that I don't forget the sign, the S-I-G-N, I'll write negative 12 here. Okay, so now we're just following SOHCAHTOA. The sine of theta, well, that was actually given to us. Opposite over hypotenuse, 5/13. And if you need to, write hypotenuse, opposite, and adjacent, if you find that helpful. Cosecant would simply be the reciprocal of sine, so that's 13 over 5. Cosine of theta, cosine is adjacent over hypotenuse, negative 12 over 13. Secant is the reciprocal, 13 over negative 12. Tangent of theta, tangent's TOA, opposite over adjacent, 5 over negative 12. And cotangent, the reciprocal, negative 12 over 5. Our next example, we have if secant theta is equal to negative 2, and theta is in quadrant 3. So we'll draw our right triangle in quadrant 3, mark theta. Secant is equal to negative 2. Now remember, secant is equivalent to the reciprocal of cosine. All right, it's the reciprocal of cosine. So if we were to write cosine theta would equal 1 over negative 2. All right. Now, cosine's adjacent over hypotenuse. Oh, but we don't want our hypotenuse. Our directed distance is always going to be a positive value. So adjacent, hypotenuse, and opposite. So this would be 1, and actually this would be negative 1, and the hypotenuse would be a positive 2. All right, because this 1 over negative 2 could also be written as the negative out in front of the fraction. All right, now use Pythagorean theorem to find our other leg of our right triangle. So we'll take 1 squared plus b squared equals c squared equals 2 squared. That's 1 plus b squared equals 4. Subtract 1, b squared equals 3, so b equals the square root of 3. So our third side here of our right triangle, or our other leg, is the square root of 3. Now this is a negative portion of my y-axis, so that I don't forget the SIGN. I'll write the negative in front of that. Okay, so now sine. Sine is opposite over hypotenuse. Negative square root of 3 over 2. Cosecant is the reciprocal. 2 over negative square root of 3. If we rationalize the denominator, we multiply by square root of 3 over square root of 3. We'll end up with 2 square root of 3 over 3. And I won't forget the negative. Let's put it can go out in front of the fraction. All right. Or it could be placed in the numerator or denominator. Cosine of theta, adjacent over hypotenuse, adjacent negative 1 over 2. Secant, the reciprocal, that was our negative 2. Tangent, opposite over adjacent. Opposite is negative square root of 3. Adjacent negative 1, so that's equivalent to simply positive square root of 3. And cotangent of theta, adjacent over opposite. Negative 1 over negative square root of 3. Again, if we rationalize the denominator, we'll multiply by square root of 3 over square root of 3. This is equal to square root of 3 over 3. So given the 1 trig function value, we found the remaining 5. And continuing with the next example, if the cotangent of theta equals negative 4 and theta is in quadrant 4. So let's draw a right triangle in quadrant 4. I'll mark our sides that are opposite, adjacent, and the hypotenuse of our right triangle. Cotangent. So we can write this as negative 4 over 1. So the tangent of theta would be the reciprocal, negative 1 over 4. Now notice here for this one, I put the negative kind of out in front. All right, so tangent is opposite over adjacent. Opposite over adjacent. So opposite is 1, adjacent is 4, and which one should get the negative? Well, this is the positive portion of the x-axis, so this is a positive 4. This here is negative y value, so this is negative 1. And the hypotenuse, using Pythagorean theorem, 1 squared is 1, plus 4 squared is 16. 16 and 1 is 17, so our hypotenuse is the square root of 17. Sine, opposite over hypotenuse, negative 1 over the square root of 17. Rationalize that, multiply by square root of 17 over square root of 17. I'm not showing that. So that's simply negative square root of 17 over 17. Cosecant is going to be hypotenuse over opposite. Hypotenuse is the square root of 17. Opposite is negative 1. So that's simply negative square root of 17. Cosine of theta, cosine is adjacent over hypotenuse. Adjacent is 4. Hypotenuse is the square root of 17. Rationalizing, we'll get 4 square root of 17 over 17. Secant would be hypotenuse over adjacent. Hypotenuse is the square root of 17. Secant 4, adjacent 4. Tangent is opposite over adjacent. Opposite, -1, adjacent 4. And cotangent is adjacent over opposite. 4 over -1, which is equivalent to -4. Remember, just check your signs again. Make sure we didn't forget any negatives. We are in quadrant 4, where sine is negative and cosecant is negative. Cosine and its reciprocal secant are both positive, because we do have positive values here. And tangent and its reciprocal cotangent are both negative in quadrant 4. Remember, checking the all students take chemistry, right? Only cosine and its reciprocal secant are positive in quadrant 4. Next on page 5, top of page 5, I'll go through the next 2 examples. It might be a good idea if you want to just stop the video and do the next 2 on your own. All right, so for number 4, if cosecant theta equals 5 over 4 and theta is in quadrant 2, we'll draw a right triangle in quadrant 2, label our theta. This is the side opposite, adjacent, and the hypotenuse. Cosecant of theta is 5 over 4. Cosecant is a reciprocal of sine, so if I'm thinking sine is opposite over hypotenuse, this is hypotenuse over opposite, right? So our hypotenuse is 5, and opposite is 4. And this is a nice Pythagorean triple. So this is a 3, 4, 5 Pythagorean triple. So the other leg of our right triangle is 5. This is a negative portion of the x-axis, so I am going to write negative so I don't forget about the sign. Now, the sine of theta, opposite over hypotenuse, 4 over 5. Cosecant, that was our 5 over 4. The cosine, adjacent over hypotenuse, negative. Oh, okay. Hopefully you didn't copy my -5. That's supposed to be a 3. Apologize. But I caught it here before I wrote down the value for cosine. All right, so cosine theta is adjacent over hypotenuse, -3 over 5. Secant would be its reciprocal, hypotenuse over adjacent, 5 over -3. The tangent of theta, opposite over adjacent, 4 over -3. And the cotangent, -3 over 4. And just checking our SIG and S, our signs. We're in quadrant 2, where only sine and cosecant are positive, and that's what we have. Our other fractions here for our 4 other trig functions are negative, as they should be. Number 5, if cosine theta equals 5/13 and theta is in quadrant 4. Okay, so we draw a right triangle in quadrant 4. In relation to theta, we have the side opposite, adjacent, and the hypotenuse. Cosine, that is adjacent over hypotenuse. So our adjacent side is 5, and our hypotenuse is 13. This is a 5, 12, 13 Pythagorean triple, so our other side is 12. It's a negative portion of the y, so I'll put -12. And now the sine of theta is opposite over hypotenuse, -12/13. Cosecant is reciprocal, 13 over -12. Cosine, adjacent over hypotenuse, and that also was given to us in its reciprocal, 13 over 5. And tangent of theta, opposite over adjacent, negative 12/5. And cotangent, its reciprocal, 5 over negative 12. Okay, now the next thing we're going to look at are trig identities. An identity is an equation that is true for any and all values of the variable. Okay, now we are already familiar with some of these trig identities. First, our reciprocal identities, which cosecant theta is equal to 1 over sine theta. Secant is equivalent to 1 over cosine. And cotangent is equivalent to 1 over tangent. And our quotient identities we also are familiar with. Tangent of theta in terms of sine and cosine is equal to sine theta over cosine theta. And cotangent would be the reciprocal of this. So it would be equivalent to cosine theta over sine theta. Now, what's new is the Pythagorean identities, right? And it's very important, and this will come up later on in another chapter. But cosine squared theta plus sine squared theta is equal to 1. And it's important to remember that, right? Given that we can get the other two, if we know this one, we can get the other two Pythagorean identities, okay? And we'll look at this, at deriving these other two at a later time. Okay, but for now, to finish up this video with the bottom half of page 5 of the notes, we want to use trig identities to simplify expressions. We want to write in terms of sine theta, cosine theta, and or both, okay? So in other words, we have, number one, we have secant theta times cosine theta. Well, we don't want secant theta. We only want our expression written in terms of sine and or cosine, okay? So no tangent, no cotangent, no secant, just sine and or cosine, and maybe sometimes numerical values as well. All right, so what we're going to do is take secant theta and write it in terms of its equivalent, 1 over cosine. So we have 1 over cosine theta, and this means times cosine theta. Well, what do we have here? Before we multiply, we've got something in common to a numerator and denominator, so they'll just divide out, and this is equivalent to 1. Number 2, tangent theta plus cotangent theta. Okay, take tangent theta and write it in terms of sine and cosine, so we'll replace it with what it's equivalent to, sine theta over cosine theta. And cotangent in terms of sine and cosine is equivalent to cosine theta over sine theta. Okay, now, well, we have to add these fractions. Well, to add fractions, what do we need? Yep, a common denominator, all right? So the common denominator, if I look at the two denominators, would be their product, cosine theta, sine theta. All right, so I'll write down equivalent fractions with denominator of cosine theta, sine theta. So what do we need to do here? We need to multiply by 1 in the form of sine theta over sine theta. So sine theta times sine theta is sine squared theta. And to take cosine theta over sine theta and to write it as an equivalent fraction with a denominator of cosine theta, sine theta, we need to multiply by cosine theta. So cosine theta times cosine theta is cosine squared theta. Okay. Same denominator, copy it. Sine squared theta plus cosine squared theta. All right, so I've got everything in terms of sine and cosine. One last thing. From above, sine squared theta plus cosine squared theta is equivalent to 1. So we can replace this with 1. So this is 1 over cosine theta sine theta. So the tangent of theta plus the cotangent of theta is equivalent to 1 over cosine theta sine theta. Next, number 3, sine. Sine of theta divided by cosecant theta. Let's see. Well, sine theta will leave. Cosecant will replace with what it's equivalent to, 1 over sine. All right. Now think of this as a complex fraction. All right. If that denominator is 1, we want to multiply by the least common denominators of these two denominators, which is sine theta. So multiply by sine theta and sine theta. Nothing divides out here. We have sine squared theta, and sine thetas divide out over 1. So this is equivalent to sine squared theta. Number 4, tangent theta times secant theta. Tangent will replace with what it's equivalent to, sine theta over cosine theta. And secant is a reciprocal of cosine. That's equivalent to 1 over cosine theta. Multiplication is nice here. All right, nothing divides out, so we just multiply across our numerators. That's sine theta, and cosine theta times cosine theta is cosine squared theta. Two more addition problems. And when you're adding, you always have to have a common denominator. So let's see, number 5, secant is equivalent to 1 over cosine, and cosecant is 1 over sine. Okay. Now I'm going to go right to the single fraction, all right? In order to add, I need the common denominator. The common denominator is the product, cosine theta times sine theta, all right? So in order to make this an equivalent fraction with this as a denominator, I need to multiply by sine theta, so I do the same to the numerator. So sine theta times 1 is going to be sine theta. And here, I need to multiply by cosine theta. So I do the same to the numerator. Cosine theta times 1 is cosine theta. That's our answer. There's nothing else we can do with that. Again, so we're taking it and writing it in terms of sine and cosine. Now number 6, sine theta plus cosecant theta. Well, sine theta we leave as is. Cosecant is the reciprocal of sine, so it's equivalent to 1 over sine theta. Let me put that over 1. I'm going to do the same thing. I'm going to go right to one single fraction with a denominator of sine theta. Okay. We need sine theta here, so we multiply by sine theta, do the same to the numerator. So we get sine squared theta. This already has a denominator of sine theta, so we just bring down the numerator plus 1. And that's it. It may look more complicated than what we started off with, but it's in the terms that we were directed to write it in. Okay, so this finishes page 5 of our notes, so thank you. This concludes our video for tonight.